The third formula we will look at is a formula to calculate the area of a minor segment, shaded here in the diagram. And the formula is the area is a half times the radius squared of theta, where theta must be expressed in radians, minus the sine of theta. And we'll actually calculate that. We may need to use our calculator, and if we do, we'll make sure our calculator is in radians and sub it into that formula. Okay, now, as always, read the question carefully, identify the key elements, and write them down as the beginning of the solution. So it says, find the exact area. Okay, well, there's quite a bit in that. At least it tells me what I'm doing. So I'm finding the area, but more importantly, it's the exact area. What comes to mind when you see the word exact? Sorts of things that come to mind are, well, we won't be going to the calculator. We would leave any square root in our solution. We would leave pi in our solution. So that's probably about it. Let's move on. So find the exact area of the minor segment. Yes, so I'm thinking minor segment, and its area minor segment is this formula half r squared theta minus sine theta of a circle if the radius is 3 and the angle subtended is 30 degrees. Got a problem here. I know if I'm going to use this formula, I have to be in radians, or the angle has to be in radians. The angle is not given in radians, so I'll have to do a conversion. Okay, what's some other things I should be writing down? I should be writing down what I'm finding. Find exact, and I think it's a good idea to actually physically write that. Exact area of segment. The radius is not a problem, it's good. The radius is given. Sometimes I'll give you the diameter, just be aware of that, but we need the radius in our formula. Theta is given as 30 degrees. Now, we know that for us to use this formula, that theta has to be in radians. If you have learnt the common conversion, angles for, or the conversion for the common angles, 30 degrees being 1, then you will know that theta is equal to pi on 6. Otherwise, you need to multiply by pi on 180, and it's now in radians. Okay, therefore, using the formula, A is half r squared theta minus sine theta, we've got the area is a half, the radius is 3, and 3 squared is 9. Theta is pi on 6. You must use pi on 6. There was a question in last year's HSC that required the use of this formula. Some students did not use the radian value for theta there and clearly were marked incorrect. Minus the sine of pi on 6. Pi on 6 is 30 degrees. It's this angle. We've got our 1, 2, root 3, and sine of pi on 6 is a half. So we've got a half times 9. So you can call that 9 on 2 times pi on 6 minus a half. What could we do? We could take out another half, take a half out, and now we'll have 9 on 4. And we'll only have pi on 3 minus 1. I think I could just leave it like that. What are they? Centimetres squared. I think you should be right now to have a look at this summary. We've got 3 formulas. Arc length, being r theta, calculating this red section. The area of the minor segment, the one we've just completed, theta must be in radians, theta must be in radians. Area of the sector, theta must be in radians. So you'd be right to do some of the easier questions from exercise 4B.